Hi, in this video I'm going to teach you how to find the sum and the product of the roots of a quadratic equation of the form ax squared plus bx plus c equal to 0 using the coefficients a, b, and c. But before I show you how to use these coefficients a, b, and c, let me show you first how we can solve this without using them. Now say for example I have 2x squared plus 2x minus 12 is equal to 0. If I just want to find the sum and the product of the roots, then that means all I need to have are the roots of this equation. And to solve for the roots of the equation, I'll solve this quadratic equation. So we have 2x squared plus 2x minus 12 is equal to 0, which can be reduced by multiplying 1/2 on both sides. And this will become x squared plus x minus 6 is equal to 0. And from x squared plus x minus 6 is equal to 0, I can factor this into x plus 3 and x minus 2, which will lead me to x plus 3 equal to 0, or x minus 2 is equal to 0, which means x is equal to negative 3, or x is equal to 2. So the roots of this equation are negative 3 and 2. So once I know the roots of this equation, it is now easy for me to find the sum and the product of the roots, because the sum is basically adding the 2. So negative 3 plus 2 is equal to negative 1, and the product is negative 3 times 2, which is equal to negative 6. So that's how you find the sum and the product of the roots of the equations if you know the roots of the equation. Okay? So how do we find the sum and the product of the roots of the quadratic equation if we don't want to get the roots of the equation? So what I need you to remember are the following. So this is the rule. To find the sum of the roots, the sum of the roots can be obtained from the coefficients b and a, and the formula is simply negative b over a. At the same time, the product of the roots is also coming from the values of c and a, and the value is c over a. So if I apply this rule to get the sum of the roots of 2x squared plus 2x minus 12 equal to 0, so if I use that same example, so equal to 0, so my a is equal to 2, my b is equal to 2, and my c is equal to negative 12. So the sum from the formula is negative b over a, which means negative 2 over 2, that's my b and a, which is equal to negative 1. And this is consistent to what we obtained a while ago. So the product of the roots, on the other hand, is c over a, and my c is negative 12, and my a is equal to 2. So negative 12 over 2 is equal to negative 6. And that is also consistent to the one we found a while ago. So from this method, we can see that we don't need to find the roots in order for us to find the sum and the product of the roots. We simply use the coefficients of the quadratic equation ax squared plus bx plus c is equal to 0. Now there are some things that you need to note when you apply this rule. The first one is that you have to make sure that the quadratic equation is of the form ax squared plus bx plus c equal to 0, meaning the degree is in descending order, that is x squared, degree is 2, then x is 1, and then a constant, and the other side should always be equal to 0. If that is not the case, you need to manipulate the given equation so that it will become ax squared plus bx plus c is equal to 0. So let me explain that using an example. Okay, suppose we have So another example. Suppose we have now 3x squared minus 5x is equal to, say, negative 7. So this is a quadratic equation, but it is not yet in the form of ax squared plus bx plus c is equal to 0. So that means we need to do something to the equation, and that is by adding 7 on both sides. So you have to add 7 and then 7 also on the other side. So this will make the equation 3x squared minus 5x plus 7 equal to negative 7 plus 7, which is equal to 0. So to check the degree, if it's in descending order, we have x squared, we have x, and we have the constant. So this is now following the format or the form ax squared plus bx plus c is equal to 0, in which a is equal to 3, b is equal to negative 5, and c is equal to 7. Now, note that if we attempt to solve for the roots of the equation, then we need to factor it. But as you can see, the only option that we have for 3x squared is 3x and x. And then for 7, we can have 7 and 1, and then interchange them later on. But this is already showing us that from 7x and 3x, the 5 can never be obtained. So that is the limitation of finding the sum and the product of the roots by first finding the roots of the equation. Sometimes it becomes difficult for us to find the roots of the equation. But since there is a method that doesn't need the roots of the equation, then we can skip that step and just use the coefficients of the quadratic equation. So to use now the new learn rule on finding the sum and the product of the roots, so we can have now, so we get the equation again. So we have 3x squared minus 5x plus 7 equal to 0, knowing that a is equal to 3, b is equal to negative 5, and c is equal to positive 7. So to find the sum is basically negative b over a, and using the values that we have, it's negative of negative 5 over a, which is 3, and this is equal to positive 5 over 3, or you can express this as 1 and 2/3. Okay, and the product of the roots, so from the rule that we have, is just c over a, which is equal to c 7 divided by 3, or 2 and 1/3. So you see, with the new method, sum equals negative b over a and the product c over a, we didn't have to determine the roots for us to find the sum and the product of the roots. Okay, so let's just summarize what we had in this session or in this video. So always keep in mind that if we want to find the sum and the product of the roots of a quadratic equation, there is no need for us to find the roots. All we have to do is use the coefficients of ax squared plus bx plus c equal to 0 and apply the following formula. Namely, for the sum it's negative b over a, and for the product it's c over a. Now again, always take note and keep in mind that the quadratic equation should follow the form ax squared plus bx plus c equal to 0 before you apply these rules. Okay, so I hope you understand my explanation on how to find the sum and the product of the roots of a quadratic equation through this video. That's it.